Lesson: Deconstructing Complex Prompts, a step-by-step approach. Deconstructing complex prompts is a critical skill in the field of prompt engineering, especially as it pertains to designing and refining artificial intelligence interactions. This lesson will delve into strategies and methodologies for breaking down intricate prompts, enabling professionals to enhance AI's effectiveness in generating accurate and contextually appropriate responses. As AI systems grow increasingly sophisticated, the ability to craft and interpret prompts accurately becomes essential. By exploring practical tools and frameworks, this lesson aims to equip professionals with actionable insights to tackle real-world challenges in prompt engineering. Understanding the structure of a complex prompt is foundational to deconstructing it effectively. A complex prompt typically consists of several components: the context, the task, the constraints, and the desired output. Dissecting these elements allows a prompt engineer to identify the underlying requirements and expectations embedded within a prompt. For instance, when presented with a prompt like, "In a detailed report, compare the economic impacts of renewable energy adoption in Europe and Asia, considering recent policy changes and technological advancements," the context involves renewable energy policies. The task is comparative analysis, the constraints include geographical focus and specific factors, and the desired output is a detailed report. Recognizing these components is the first step in deconstructing a prompt, setting the stage for more precise execution. A key framework that aids in deconstructing prompts is the Q method, which stands for context, understanding, and execution. This framework assists professionals in dissecting a prompt by methodically analyzing each component. Context involves identifying the background information and setting relevant to the prompt. Understanding requires comprehending the prompt's core objective and the nuances involved. Execution focuses on developing a strategy to address the prompt effectively. Applying the Q method enables prompt engineers to systematically dissect complex prompts, ensuring no critical detail is overlooked. The utility of the Q framework can be illustrated through a case study involving an AI tasked with generating content for a global marketing campaign. The prompt provided was, "Create a marketing strategy for a new eco-friendly product that appeals to diverse cultural audiences across North America, Europe, and Asia, emphasizing sustainability and affordability." By applying the Q framework, the AI's developers first identified the context: a marketing strategy for a new product. Understanding involved recognizing the need to appeal to diverse cultural audiences while emphasizing sustainability and affordability. Execution required tailoring the strategy to different regional markets, considering cultural nuances and economic factors. This systematic approach enabled the AI to generate a nuanced and effective marketing strategy that resonated across different regions, demonstrating the practical application and effectiveness of the Q method. Another practical tool that enhances the deconstruction of complex prompts is the 5 whys technique, a problem-solving method that involves asking why repeatedly to uncover the root cause of an issue. In prompt engineering, this technique can be adapted to explore the underlying assumptions and requirements within a prompt. By questioning each aspect of a prompt, professionals can gain deeper insights into its construction and intent. For example, when tasked with generating a report on the impact of artificial intelligence on healthcare systems in developed countries, a prompt engineer might ask, why focus on developed countries? Why healthcare systems? Why the impact of AI specifically? These questions help clarify the prompt's purpose and guide the engineer in crafting a response that aligns with the intended objectives. Statistics and data play a crucial role in deconstructing prompts, especially when they involve complex analyses or comparisons. Utilizing reliable data sources ensures that the resulting outputs are grounded in factual information. For instance, when tasked with analyzing the economic effects of renewable energy adoption, a prompt engineer might rely on data from the International Energy Agency or the Renewable Energy Policy Network for the 21st century to support their analysis. By integrating credible data into the deconstruction process, professionals can enhance the accuracy and relevance of the outputs generated by AI systems. Moreover, leveraging collaborative tools and platforms can streamline the deconstruction process, facilitating effective communication and collaboration among team members. Platforms like Trello, Asana, or Slack enable prompt engineers to organize tasks, share insights, and track progress in real time. By fostering a collaborative environment, these tools allow professionals to pool their expertise, ensuring a comprehensive approach to deconstructing complex prompts. This collaborative aspect is particularly valuable when dealing with multidisciplinary prompts that require input from experts in different fields. To further illustrate the application of these tools and frameworks, consider a scenario where an AI is tasked with developing a policy proposal for reducing carbon emissions in urban areas. The prompt: design a comprehensive policy proposal that addresses carbon emission reduction in urban areas, considering transportation, industry, and residential sectors, requires a multifaceted approach. By employing the Q framework, the prompt engineer can identify the context, understand the task, and execute the strategy by focusing on specific sectors. Applying the 5 whys technique further clarifies the prompt's assumptions, such as why focus on urban areas or why include specific sectors. Utilizing data from credible sources like the Global Carbon Project ensures the proposal is grounded in factual evidence, enhancing its credibility and effectiveness. In conclusion, deconstructing complex prompts is a multifaceted process that requires a systematic approach, strategic frameworks, and practical tools. By applying the THEW framework, professionals can dissect prompts into manageable components, ensuring a comprehensive understanding and effective execution. The 5 whys technique aids in uncovering underlying assumptions, while reliable data sources and collaborative platforms enhance the accuracy and efficiency of the deconstruction process. These methodologies not only address real-world challenges in prompt engineering, but also enhance proficiency in crafting and interpreting prompts. As AI systems continue to evolve, the ability to deconstruct complex prompts will be pivotal in optimizing their performance and ensuring they deliver accurate and contextually relevant responses. Pause.